And we continue our subject with amines. So we stopped here last lecture. Today I will continue with you. So we talk about physical properties of amine. Primary and secondary amine have higher boiling point than similar compounds like ether, okay, incapable of hydrogen bonding. Why? Because the ether cannot be make hydrogen bond. There is no hydrogen bond with ether compound, okay? So, but lower boiling point than alcohols that have stronger intermolecular hydrogen bond. Okay, now look to here. If you look to here, the first compound is the ether, and the second one amine, and the second one is alcohol. So with the same molecular weight, look here, the same molecular weight, look the difference between the boiling point. The first one is how much? 38. And the second, 78. Look, much different between of them. Why? Because the ether cannot be make hydrogen bond, and the amine can make hydrogen bond, okay? So if you compare the amine with the alcohols has higher boiling point than amine, but both of them has hydrogen bond. Amine has hydrogen bond, and the alcohol also has hydrogen bond. What do you think? Why this difference between of them? Okay, oxygen is higher electronegativity atom, and what will we make if you talk about the oxygen? Stronger hydrogen bond. How it will be stronger? Yes, you're right. Stronger hydrogen bond, but how? What do you think? Now, look. This is the nitrogen atom. Yes, the nitrogen unshapered electron, and we have here two hydrogen. If we talk about the primary amine, okay, and also you have alcohol compounds. This alcohol, we have two unshapered electron. What is the difference between oxygen atom and nitrogen? As you said, the electronegativity atom. Okay, if you talk about the electronegativity atom, you say the oxygen is higher electronegativity atom than nitrogen. So anyone, it's easy to give the unshapered electron, the nitrogen or the oxygen? No, stronger electronegativity atom, low the electron, that cannot easy to give, to share the unshapered electron. If you think like that, the hydrogen bond, it will be reversed, it will be weaker, the hydrogen bond. Okay, think about the other side. If you say this is higher electronegativity atom, that meaning the hydrogen here, it will be decrease the electron density more than what we seen in the amine. So this oxygen higher electronegativity atom than nitrogen. That meaning it will be withdraw the electron density from the hydrogen atom and make the hydrogen electron deficient. It will be partially positive. Okay, but the nitrogen also withdrawing group, not like withdrawing atom, not like oxygen. Also, it will be make the hydrogen electron deficient, but smaller than what that seen in the alcohols. It will be like that, partially positive. Okay. Now, when this has bigger or higher or stronger partially positive, that meaning can be make hydrogen stronger hydrogen bond with another molecule. For this reason, the hydrogen bond in alcohol, it will be stronger than the hydrogen bond in amines. Okay, do you understand? Do you understand? This is the reason. If I say to you why the hydrogen bond in alcohols is stronger than the amines, this is the answer, okay? It will be related with the electronegativity of the atom, the difference between oxygen and the nitrogen. So, look here, increasing intermolecular forces and increasing boiling point. Okay. Tertiary amines have lower boiling point than primary and secondary amine. Why? It is clear. Why tertiary amine? Tertiary amine has lower boiling point, melting point. This, all of them, they are R group. Why? Because there is no hydrogen. There is no hydrogen bonded to the nitrogen, and that meaning there is no hydrogen bond. Because there is no hydrogen bond, amines cannot be make, okay? Cannot be make hydrogen bond. Tertiary amine cannot be make hydrogen bond. What that's seen in primary and secondary amine. Okay, because they have no nitrogen hydrogen. There is no nitrogen hydrogen bond and are incapable of hydrogen bonding. Cannot be make hydrogen bond. Clear for you? This about physical properties. No. Amines are soluble in organic solvent regardless طبعا دائما regardless of size. Not all the amines they are soluble in water. Okay? Depend on the size, depend on the hydrophobic part. Depend on the hydrophobic part. Okay? If the hydrophobic part is small amines, yes, can be soluble in water, but with bigger structure amines cannot be soluble in water. Okay, is it clear? So all amines having less than 5 carbons are what? Are water soluble. Are water soluble because they can make hydrogen bond with water and can be soluble in water. Amines having more than 5 carbon atoms insoluble in water. Why? Because the nonpolar alkyl, we say the part of the hydrophobic part, it will be bigger, okay? Because the non-polar alkyl portion is too large to dissolve the polar in the H2O solvents. Depends on the size, depends on the hydrophobic. This is the hydrophobic part of the amines. Do you understand? So now what about the physical properties of the amine? Now we go to the preparation of the amines. There is three types reactions to prepare of amines compound. 3 principles to prepare of the amine, or 3 main principles to prepare the amine compounds. Number 1, nucleophilic substitution. Using what? Using nitrogen nucleophile. And you know this reaction is all of them by SN2 reaction. All of them we talk about and explain by one by one. Secondly, reduction of other nitrogen containing functional group. Other nitrogen compounds can be reduction, okay, to give you what? To give you the NH2 group. Third one, reductive amination of aldehyde and ketone. This is the third one. Reductive amination of aldehyde and ketone. And we start with the nucleophilic substitution rules to the amines. He said nucleophilic substitution is the key step to what? In 2 different methods for synthesize the amine. This about the first one, nucleophilic substitution. Firstly, direct nucleophilic substitution. And secondly, Gabriel synthesis for primary amine. Now, what meaning direct? This is the first one. What meaning the direct nucleophilic substitution? Okay, direct nucleophilic substitution is the simplest method to synthesize the amines by what? By SN2 reaction. And you know what meaning SN2 reaction. Okay, you know what meaning SN2 reaction is one-step reaction and is preferred with alkyl halide. Any alkyl halide, primary, secondary, tertiary? SN1, SN2, with any? Yes, with the primary alkyl halide is the preferred one, and we take it inshallah. So the SN2 reaction of an alkyl halide with what? With NH3 or an amine. The method is required two-step one. Nucleophilic attack of the nitrogen nucleophile forms ammonium salt. Secondly, removal of proton from the nitrogen atom to give you the amine. So if we go to this like that, here we have, for this example, we have CH3Br. This alkyl halide, yes? And we have nucleophilic atoms, like take the small one, the ammonia, NH3. Now, if we say this ammonia, it will be react with methyl bromide or bromomethane, okay? That meaning this antiprophilic electron directly attack the carbon, and this the Br is leaving group. It will be leave the structure and give you what? What is the product for this 2 reaction? By SN2. By SN2, it will be give you what? Give you N. Look, edge, and CH3 plus Br minus. Now the nitrogen here, it will be take positive charge. Why? Because lost the electron to make a new bond, and the nitrogen now is 4 bond. It will be take positive charge. So always I said to you before that, maybe in the last year, If I say to you, for every nucleophilic attraction, okay, attack, when your nucleophile is neutral, you will have one access step. One access step. Now, what is the step now to make this compound in neutral? How we can make this compound to remove the positive from here? Is deprotonation, remove proton. What is the base here, or to remove the proton is the Br minus. That meaning the Br minus, it will be remove the proton, and this both the electron, it will be go to the nitrogen atom to give you the final product. The final product is the amine. Amine is the amine. This what we talked about it here in this slide. Okay, is two steps. Step number one, nucleophilic attack, nucleophilic attack. Okay, nucleophilic attack. Step number two, remove proton to give you the final product. Two خطوة, 1, 2. This is clear? Okay, I think simple reaction, nothing complex here. So if you use ammonia, what is the product? As we said here, primary amine. If you use primary amine, what is the product? Secondary amine. If you use secondary amine, it will give you tertiary amine. If you use tertiary amine, it will give you salt. There is no proton to remove, and the final product, it will remain like that. It will be salt, ammonium salt. Ammonium salt. Okay? Do you have a question? Do you have a question? This direct nucleophilic substitution. Okay? Direct nucleophilic substitution. This is the direct nucleophilic substitution. So, secondly here, he said, or by direct nucleophilic substitution, this is the direct nucleophilic substitution, or by Gabriel synthesis of a primary amine. Okay. What is the problem here with this substitution? We have one problem here. I will explain for you here. Look, the direct of the nitrogen nucleophilic determine the type of the amine, as I said to you before that. If you use ammonia, it will give you primary amine. If you use a primary amine, give you secondary amine, like that, okay? So it will be determine the type of the amine or the ammonium salt formed as a product. So when a new carbon-nitrogen bond is formed in each reaction, because the reaction is what? As follows in, okay, thank you, in SN2 mechanism. The alkyl halide must be anhydride alkyl halide, because our mechanism is what? Is SN2. That meaning, if you use this alkyl halide, for example, here, this alkyl halide, مثلا BR here, we have CH3, 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 okay? And you know, you want to prepare the amine from this reaction, the ammonia with this compound, tertiary alkyl halide, this cannot be happened by what? By SN2 reaction. Cannot be happened by SN2 reaction. Okay? This also limited to prepare the amine compound by direct substitution. Not all the amines that you wanted, it will be prepared by this method. Okay? It's limited. This is about the limitation of the alkyl halide. Okay. It will be anhydride alkyl halide. That meaning maybe can be used, as I say to you, the methyl halides, or can be used the primary alkyl halide. Just this. Okay? Also, this process seen straightforward polyalkylation. Here's the problem. We have polyalkylation of the nitrogen nucleophilic, and this reaction also as the side product. What do you think the polyalkylation of this compound? Okay, just give me 1 minute. Keep silent, please. Look. This, you have, for example, you have a reaction between, I will take simple reaction, okay? Between this CH3, for example, okay, Cl, no problem, plus NH3, what is the product? Okay, what is the product? Now, firstly, if we think about this reaction can be happened, not just one molecule with one moleculus, okay? That meaning you have round, this round, have both of the compound. The ammonia as a gas, okay? And for example, you have many molecules of what? Of CH3Cls. And by gas, for example, the ammonia, also it will be many molecules of the NH3. So firstly, the first molecules from the alkyl halide, it will be react with NH3. Give you what? Directly give you this. Directly give you NH2 CH3 NH2. Also this as a product can be also react with the alkyl halide again. When you have a product here, also the product can be react with another molecules from the starting material. Okay, and this also can be react with the CH3Cl again. Okay, that meaning we have unshape of electron, this unshape of electron attack, and this will be leave, give you what? Give you CH3 NH CH3. That meaning you have a primary amine, you have secondary amine. Also secondary amine can be react with another starting materials and give you tertiary amine. That meaning we have mixtures of product. We have the primary amine, we have secondary amine, we have also tertiary amines. This is the problem with direct amination. You cannot control just if you want the primary amine, give you just the primary amine. No, it will be give you primary amine, but also give you secondary amine, give you mixture product. This also problem when you make the reaction. Do you understand? This also problem when you make the reaction. For this reason, we said polyalkylation can be happened. Polyalkylation of the nitrogen nucleophile, it will be also can be happen in this reaction also as a side product. This also bigger problem and direct alkylation to prepare the primary amine. So any amines formed by nucleophilic substitution still has non-bond electron pair other amine. This amine that it will prepare from this reaction still has unshape of electron. That meaning it will be making it nucleophile as well further. Okay. That meaning any amine you prepared also has unshape of electron can be react with your starting material. This amine has unshape of electron can be react with the tertiary amine has unshape of electron can be react with the starting material. This is bigger problem. Okay, you cannot control your reaction here. Okay, the problems with the direct substitution to prepare the primary amines. Okay, so what you have to do in this time will react with the remaining alkyl halide to form what? To form more substitution amine. Because of this, a mixture primary, secondary, tertiary amine often results, as I said to you. Okay, only the final product, quaternary ammonium salt, just the final one. When you have this CH3, sorry, N, this is the N, CH3, this as salt. Just this amine cannot be react with the starting material. Why? Because there is no unshape of electron. Just the quaternary amine cannot be react with the static material. Called the quaternary ammonium salt because it has 4 alkali group, okay, and there is no unshape of electron. And your reaction will be stopped. Your reaction will be stopped here. So as a result, the reaction is most useful for preparing primary amine by using what? By using very large excess of the nucleophiles. Okay, so if your nucleophile here ammonia, you will be put excess amount, big amount of the ammonia, and a small amount from the alkyl halide. Why? To prevent the secondary and tertiary and polyalkylation. To prevent the polyalkylation. Yes, how many possible you will be take it, but in different percentage. Okay, I don't know the percentage, but it will be different percentage. Yes. Yes, if I say to you, مثلا, this reaction, write the product, you will be write the primary, secondary, and tertiary like that. We have polyalkylation can be happened. Okay, as I said to you, this procedure it is not useful to prepare the primary amine. Why? Because the side product, we say side product, and have a side product. You don't want this. You don't want this. You want just this. Yes. Okay. So. As a result, the reaction is most useful to prepare the primary amine by using what? By using large excess of the ammonia. I will use many different size or different amount, big amount of the ammonia and a small amount of the alkyl halide. Why? To prevent the or decrease the side product, decrease the side of products here. You'll be large amount of the nucleophile, large amount of the nucleophile. Okay? So, here, and to prepare quaternary amine salt, if you want to prepare the quaternary amine salt by alkylation and nitrogen nucleophile with one more equivalent of the alkyl halide. If you want to prepare the quaternary ammonium salt, what we have to do? You have to use much amount of the alkyl halide. Tamam? Yani reverse to other. If you want to just to prepare a quaternary ammonium salt, okay, directly use big amount of the alkyl halide. If you use to increase the percentage of the primary amines, use big amount of the nucleophiles, like that. Okay, that meaning you have to control your reaction. You have to control your reaction. Anyone it will be used with big moles, with big amounts. So look here to this reaction. What he said here, excess يعني زايدة. That meaning the main product will be what? For you, it will be primary, not secondary, tertiary. Yes, يعني this may be مثلا 90%, and the secondary, tertiary it will be small percentage. Yes, when you use excess amount of the ammonia. When you use excess amount of the ammonia. Look to this reaction. This is primary alkyl halide, and this what? Primary, secondary, tertiary. What this I mean? Tertiary. Yani directly your product it will be what? Salt. It will be ammonium salt. Directly the product it will be ammonium salt. Okay. There is not another. There is no another product. Just one product here. Okay. One product here. So this is the homework. This is the homework. Draw the product of each reaction. Tamam. This reaction. Look. He said what he said here. Excess. Okay, excess يعني زايدة. That meaning the main product it will be what? Primary amine. Just Cl raka, remove the Cl and put NH2. This is the answer. Okay, look here. Excess what? Alkyl halide. That meaning what is the main product here? The quaternary ammonium salt. Okay, be careful. It will be the quaternary ammonium salt. It will be ammonium salt, the main product. Okay, you have to be careful when you write the product. Is it clear? Do you have a question? Do you have a question? This about direct substitution. Okay, this about direct nucleophilic substitution. Okay. Now the Gabriel synthesis. What is meaning Gabriel synthesis? Why we use Gabriel synthesis? Okay. Now the Gabriel synthesis of a primary amine for what? Just the primary amine, طلبة. There is no secondary and tertiary amine, and we will see why it is just for primary amine. Okay. To avoid polyalkylation, يعني to avoid the polyalkylation, to avoid the secondary amine, to avoid the tertiary amine, okay, to avoid the quaternary ammonium salt, okay, to avoid the polyalkylation, nitrogen nucleophile can be used that reacts in single nucleophilic substitution. Just one substitution nucleophilic it will be happened here. Okay, in single nucleophilic substitution, that is the reaction forms a product that doesn't contain a nucleophile nitrogen atoms capable to make reaction further. Okay, the product from the first step cannot be able to make further substitution here. Okay, how we will be see here. The Gabriel synthesis consists of two steps, two خطوة, okay, two steps, and uses for what? Uses resonance stabilized nitrogen nucleophiles to synthesize primary amine via what? Via nucleophilic substitution. I will give you here what is the meaning here. The Gabriel synthesis begins with what? With phthalimide. This is the compound. This is the phthalimide. Okay. One of the group of the compound called imides. This is the type of the compound that have nitrogen and have double carbonyl group bonded to the nitrogen. We say this is the imides. Okay, this is the imides compound. This is the imides compound. The nitrogen hydrogen bond of the amines is especially acidic. If I say to you, why this compound can be this compound acidic or not? Can be this compound acidic or not? What you have to do? Write the conjugated base. Okay, remove the proton. Remove the proton. Where's the conjugated base? This is the conjugated base. If the conjugated base is stable, يعني acidic. If the conjugated base not stable, يعني not acidic. Okay? Now remove a proton. This is the proton. This is the conjugated base. Now we have resonance structure here. Yes, we have this with this carbonyl group, also with this carbonyl group. That meaning we have resonance from here. Also we have resonance from here. We have 1, 2, 3, 3 resonance structure. That meaning the anion is especially what? Stable. That meaning the compound, it will be what? Acidic. This compound, this proton, it will be acidic proton, can be deprotonized by using what? By using base. Now, this is the first step. Okay? This is the first step. An acid-base reaction, this acid-base reaction to form nucleophilic anion that can direct with the unhindered alkyl halides, like as I tell you, primary alkyl halide or the methyl halides. And what? In SN2 reaction. That meaning this your nucleophile now. This your nucleophile now. It will be attack. It will be attack the alkyl halide. Okay, it will be attack the alkyl halide. So to give you what? To give you primary amine and then decarboxylation to give you the final product. So this reaction is similar to the hydrolysis of the amide to afford the carboxylate anion and the amines, and it will be here the reaction, all the reaction. Look, first step, as I say to you, this is the first step, is acid-base reaction. Okay, you have the phthalamide and it will be react with the base to give you the your nucleophile. This is the negatively charged nitrogen, and it will be stabilized by using resonance. This is your nucleophile now. This second step, the nucleophile, this is the nucleophile, it will be react with the alkyl halide. By what? By SN2 reaction. To give you this alkylide imides. This is the alkylide imides. Okay, this is the alkylide imides. Now, alkylide imides go to the hydrolysis with water. Like you take it, if you remember the amides last year, the hydrolysis of the amide in basic medium. Do you remember? Okay, we have mechanism how the amide, it will be hydrolysis with water in basic medium. Okay, in basic medium, this the same mechanism, but we don't take the mechanism now. In easy way, the OH, it will be attack the carbonyl and it will be open to give you carboxylate. Also another OH, it will be also attack this carbonyl group, also to give you the carboxylate anion. That meaning the final product is a primary amine and dicarboxylate anion. This is the final product. Okay, this is the final product. I think it is clear for you, but here. Okay. I will use this maybe. Now this R group, oxygen and this oxygen, and we have here. Okay, this alkylide amines. Okay, with base by using basing and water hydrolysis in water in basic medium, hydrolysis in basic medium. What happened? This bond between nitrogen and carbon, it will be what? Breakdown, and this also it will be a breakdown. And to give you this part, it will be give you what? Give you primary amine, and this part give you. Look, this. Here is we have carboxylate. This is the carboxylate minus. Also this part, it will be have another carboxylate. We said dicarboxylate compound, and the primary amine. Look, just we have what? Just we have primary amine here. Just we have primary. We don't have secondary. We don't have tertiary. This is indirect alkylation by using Gabriel synthesis. Okay? Indirect alkylation by using Gabriel synthesis. Do you understand? The Gabriel synthesis, do you understand? Do خطوة. خطوة أولي is to prepare the anion acid-base reaction, the base with the phthalaamides to give you the amides, okay, anions, and then the anions it will be used to attack with the alkyl halide, If you have a question or anything not as clear for you, let me know. No questions? No question? Okay. Okay. Just be patient. The Gabriel synthesis convert the alkyl halide into primary amine by two-step process, nucleophilic substitution followed by hydrolysis. This is all the process. So, example, this is our example here. I say to you this, it will be attack and remove the Br, give you this compound, alkali amides hydrolysis, give you the final product. Overall process is to change the halogen with what? With NH2. To change the halogen with NH2. Substitution. Overall process is substitution. Tamam? Overall process is substitution. So, here, this homework, he said, what alkyl halide is needed to prepare each primary amine by Gabriel synthesis? Which what? Which alkyl halide? Any alkyl halide? NH raka, NH remove NH, take Br. Here, the same thing. Remove NH, BrCl as you want. Here, remove NH, take BrCl. This is your alkyl halide. Okay? Secondly, which amine cannot be prepared by Gabriel synthesis? We said Gabriel synthesis to prepare for what? Primary amine. Which amine cannot be prepared by Gabriel synthesis? This can be prepared. Why? Because if you put here Br, it will be aromatic alkyl halide, aromatic halide, aryl halide, and aryl halide cannot be used, cannot be entered to the SN2 reaction. So this cannot be prepared by Gabriel synthesis. And this, yes, why? Because if you put here Br, the Br it will be primary alkyl halide and it can be prepared. This, yes. This, no. Why? Because this secondary amine and Gabriel synthesis just to prepare primary amine. This, if you remove the Br, yes, it will be has tertiary alkyl halide. Tertiary alkyl halide cannot be used in SN2 reaction. This cannot be used. Okay, look, it will be like that. Tamam? Do you understand? Okay. Reduction of other functional group that contain nitrogen. Okay? Okay, be patient, just two slides. Okay. Reduction of other functional group that contain nitrogen. Amines can be prepared by reduction of nitro compound. This you know, this reaction. Okay? This reaction. Nitrile and the amide. Okay? Any one of them, look, talaba with me. Amines can be prepared by reduction of what? Nitro compound. What? Nitrile. What? Amide. Okay? Because the details of these reactions have been discussed, and we take it before that, and I will see you here the first reaction from nitro compound. Talaba. Nitro groups are reduced to primary amine by using variety of the reducing agent. You have NO2 it will be converted to NH2 by what? By hydrogen and metal catalyst, hydrogen catalyst, metals with HCl, okay, SN with HCl, all of them. طبعا there is also another reagent, but this the easier ones can be used directly. Convert the NO2 to the NH2. There is no mechanism, just general reaction. Okay, every NO2 can be reduced to the NH2 by using these reagents. Okay, this is the first one. Secondly, from nitrile compound. Nitrile compound. This is the nitrile compound. How we can prepare the nitrile compound? Do you know? How we can prepare the nitrile compound? Also from also by SN2 reaction, by nucleophilic substitution. Okay, if you have this alkyl halide, talaba, this alkyl halide Br, and it will be react with what? Look here with Na CN, this is the NaCN. Directly, this is the nucleophile, and this is the positive for the nucleophile. Okay, this is the nucleophile, directly nucleophile attacked by what? By SN2 reaction, and give you what? Give you RCN. This is the RCN. This is the natrilyl group. This natrilyl group. Now, if we want to reduce the natrilyl group with the hydrogen, that meaning to break this pi bond, need to what? Need 2 hydrogen. Okay? To remove this bond. To remove the second bond, also need 2 hydrogen, another 2 hydrogen. Okay? That meaning give you what? Give you primary amine. Give you primary amines. Okay? Give you primary amines. One other reagent can be used here is lithium aluminum hydrate and H2O, two-step reaction to reduce the natrilyl group to the primary amine. Thirdly is the primary, this we know it here, primary from the amide. This is the amide group. Also, this amide can be reduced by the same group, lithium aluminum hydrate and H2O, also to convert the C double bond oxygen to what? To the CH2O. This is the amide. Here. This is the amide. Directly convert this to what? To the CH2 by the same reagent. There is no mechanism here. Just take the reaction. Okay? Just take the reagent. Amide, primary amide, give you primary amine. Secondary amide, give you secondary amine. Tertiary amide, give you tertiary amine. Just like that. Okay? By the same reagent. Do you have a question? Do you have a question? No question. This homework for you. And I will stop to here. I will stop to the reductive amination. Okay? But we want to see the homework. This homework for you, but I will give you the idea. Okay. Now, what nitro compound, natrilyl and amide are reduced to each compound? Yani, do you understand the question? He said, this is the amine. What is the nitro compound can be converted to this amine? What is the natrilyl compound can be converted to this amine? What is the amide compound can be converted to this amine? Okay? So, what is the nitro compound? Just put here NO2. What is the natrilyl compound? Put C triple bond nitrogen. Okay? C triple bond nitrogen. For example, I will resolve the number B. B for you. This number B. CH2 NH2. Yalla. What is the nitro compound? Any compound? This is the nitro compound. CH2 NO2. Okay. What is the natrilyl compound? This is the natrilyl compound. C triple bond nitrogen. Yeah, natrilyl compound reduction, it will give you this. Nitro compound reduction give you this. Okay, what is the final one? What is the amide? What is the amide? Yes, good. Primary amide. This is the amide. This is the amide. Reverse reduction give you this. Okay? This is the homework. Okay. What amine is formed, the second one. What amine is formed by reduction of each amide. Other amide, reduction, any amine give you. Just convert the CO to what? CH2. خلاص. Convert the CO carbonyl group to the CH2. This is the carbonyl group to the CH2. Okay. Explain why isopropyl amine, this isopropyl amine, can be prepared by reduction of the nitro group. This can be prepared by the reduction, but cannot be prepared by reduction of natrilyl, even it is a primary amine. Bucci, this cannot be prepared by reduction of natrilyl. What do you think? Okay, we try. We try. This, where is it? This CH3 what? CH3. CH3. Hydrogen, yes. And then NH2. Okay, why cannot be prepared by natrilyl? If we want to convert this to the natrilyl, it will be what? It will be CH3. CH3. Okay, here, a triple bond nitrogen, this right? This right? No, Cannot be. Why? Because the carbon here it will be 1, 2, 3, 4. That meaning cannot be prepared by nitrogen because the carbon directly bonded to the NH3 is what? Is substituted. Is substituted.
Because the preparation of nitrile is a two mechanism and cannot be
Okay, but the nitrile you have to prepare the nitrile compound firstly. Okay, how you can prepare the nitrile here? From the alkyl halide. Okay, think about it. It is homework, it is homework. Which amine cannot be, Allah, the final one. Which amine cannot be, but I give you the answer. The answer here, because the carbon directly bonded to the NH2 is substituted. Okay, substituted. I cannot substitute مثلا hydrogen تدهية. There is the hydrogen, it is not enough. You have to at least 2 hydrogen. Okay, at least 2 hydrogen. Now, which amine cannot be prepared by reduction of an amide? Reduction of what? An amide. This can be prepared by reduction of amide? This? No. Why? Because there is no carbon, carbon directly bonded to the nitrogen. It is just aromatic here. This can be prepared by reduction of amide? Yes. Why? Can be you make here carbonyl compound. Can be make amide. Okay. This can be prepared from the amide? No. Why? Because here it's substituted. Okay. This can be also because substituted. The carbon directly bonded to the nitrogen, they are substituted. Okay. For this reason, cannot be prepared by the amide. And I will stop here to the reductive amination of aldehyde and ketone. If you have a question, please ask me. If you don't have a question, inshallah, see you next lecture. Okay.